Hi everyone, update 8 part B, or part 2. Apologies for the delay in the second part. My laptop power supply died and I had to abandon the recording halfway through. Okay, say hi to Tux on the desktop. Right. This is a diagram showing where all the energy, all the power that's being used by my Bedini and where it's going. So, should be able to see my mouse on this one. So, battery is here, not drawn. Simple reason being don't need to. Right. Every figure in black is what's been recorded direct from a multimeter. Granted, digital multimeter, but it is an expensive one, as I've said all along. Right, and of course down here as well. This value calculated in green is one that's been calculated. Same goes with this one. So let's start from the beginning. We know that my Bedini has a deficit of 2.6 milliamps at approximately 12 volts. Right. We know that because it's been recorded and I've shown it on videos. Right. Now I also know by sticking the same multimeter between the cat bank and the Bedini that it's actually drawing about 46 milliamps before it tries to recover anything. And of course you've got the Bedini itself. Now we know the laws of physics state that energy cannot be created or destroyed, so we have a system that we can easily map here. Right. Out of my Bedini we have a load of losses, right, and I've grouped them all together. Right. I've put the electromagnetic field of the drive coil in, as well as heat created. We have sound, which DREVTOOBE has actually pointed out to me that sound eventually turns back into heat anyway, but for simple terms I've just put the primary losses rather than the resultant losses. Kinetic energy, well, that's quite simple really. Because you've got a spinning rotor, some of the air that's touching the rotor will be moved. Ergo, you're taking energy out of the rotor and putting it into the air. Now again, DREVTOOBE pointed out that that energy, kinetic energy that's been lost by transferring it to moving air, again turns back into heat. But as I've already said, we're dealing with primary losses, not resultant losses. Right, chemical. I've included that with a question mark because there has to be some sort of chemical loss because I'm using a cat bank. Right, so the inside workings of the capacitors have to lose energy somehow. It can't be 100% efficient. So there is, even if it's 0.1%, it's still there as a loss. So what I've done here and what I've shown is that I've included all of the EM field as a loss. As a result, my Bedini is losing 0.552 watts. That's before any recovery system whatsoever. Right. Now, the interesting thing to note is Bedini himself has advertised the 1 watt challenge. So to create a device of some sort that produces 1 watt of power in excess of what it uses. That's twice what my Bedini actually uses without any recovery whatsoever. So for my Bedini to produce in excess of 1 watt, its efficiency is going to be like 300%. So that could be an interesting one. Right, as I've already said, on my Bedini there is various recovery systems. So let's take a look. Sources of energy down here. Right. Drive coil. Right, we'll start with the simple ones. On the drive coil, those that remember my circuit diagram will note the additions of diodes 3 and 4. They turn the drive coil itself into a generator on bipolar systems. Now, sticking a multimeter in, it comes back giving approximately 10 milliamps. Roughly, it varies, and there's inaccuracies with the multimeter, etc., etc. So I've just given it a round figure of about 10 milliamps. Right. Gen coil A, that's the windings around the back of my drive coil, and that's producing approximately 15 milliamps. Gen coil B is the coil that's wrapped around the outside of the bipolar windings, and that's producing approximately 12 milliamps. So we can calculate that it's recovering rather, 43.4 milliamps. Now I've calculated that based on that figure and that one. Basically that take that. So 2.6 milliamps take, 46 milliamps take 2.6 milliamps, gives you that figure. Yes, I know these figures here do not add up to that one, for a simple reason being when you stick a multimeter in the circuit to measure current, it introduces a little bit of resistance, which changes the values. So you're never going to get an exact figures when you're dealing with this small amount of current. Okay, as such, I have calculated, right, it does depend on how you want to look at it, but I've calculated that my Bedini is 94.34% efficient. That is extremely high. The other way that you could calculate it is that because the output from the Bedini is being fed back to the input, as shown here, right, you could theoretically say that it's actually 0% efficient because it's still drawing power from a battery. Well, I'm going to let you lot argue that one out, because I've sort of argued it with myself and, well, got nowhere. So any sort of closed loop system like this one, right, it will only ever be 100% or higher. It'll either be 0%, 100% or higher. So I'll leave you guys to argue that one as necessary. Stored energy. Now, I've got question marks in here at the moment because I don't know what's actually being stored. The rotor itself is spinning at a constant speed-ish, so therefore we can calculate how much kinetic energy is stored in the rotor, but I haven't done that yet because it's kind of complicated to do. Oh, phew. Someone would message me. C1 and C2 have power stored, but as yet are not being used. So eventually those two, C1 and C2 are the back EMFs produced by the trigger coil and drive coil. So eventually they will get moved from stored energy to sources of energy. Okay, any questions, give me a shout. Cheers.